Welcome back. Section 5.3, we're going to start our business and interest section for calculus here. And the first thing we're going to talk about is interest. And we've talked about interest before. We started back in Algebra 2. We talked about simple interest and compounding interest. And we're going to do the same thing here today. We're just going to review those things and maybe give you a couple of examples on where we could see it. We'll also give you some other formulas that you'll need to have. So all these formulas are going to be important to us. So you may want to copy those down and write them down, put them somewhere safe so that you can come back and look at them. So our first interest type that we're going to talk about is simple interest. And a lot of banks will do simple interest for you. It's basically just interest that we earn on an investment. I guess we should talk about what an interest is to start with. We probably all have a bank account, some kind of savings or a checking account in which we put money in, and then we earn money on that money that the bank gives us to keep our money in there. So that's kind of what we're going to be working with today. So with our formula for simple interest, we can calculate the amount of interest that we earn. Our interest is going to equal the P, which is going to be our principal, and the principal is what we put into it, so it's going to be our P value. Our R is going to be the interest rate at which we earn, and that's going to be at the percentage. So if it's given you at 3%, we got to change that to a decimal to 0.03. Remember, change that decimal or percent to a decimal, we move the decimal place 2 places to the right. And then T is going to be our time in years. So if we want to know the simple interest that we're going to earn, say we have $300 that we're going to invest for our principal, and we get a 5% interest rate, which is pretty good at this point in time, and say we do it for 1 year. Well, if we do it for 1 year, then we're going to take our interest that we have, and that's going to be 300 times 0.05 times 1. And if I take 300 times 0.05, or 5/100ths, I end up with 15. So my bank account will have $315 in it at the end of 1 year. Well, if I think about my second year, if I do for 2 years, so maybe 2, and I keep my 5% and my $300, I'd have 300 times 0.05 times 2. In this case, I would earn $30. So at the end of the second year, I'd have $330. And we can do this for as many years as we want, but we only earn interest on the balance or the principal that we originally put in. We do not earn interest on any of the interest that we have. That's where compounding interest comes in. Compounding interest, we earn interest on that money that we put in originally, and then the next year we'll earn money on the interest that we occurred over that second year, or that first year. So we have a formula here, A equals P times 1 plus R over N to the NT. And we've used this formula before. Again, P is going to be our principal. R is the rate. Again, that's going to give you as a percent, but we need to change that to a decimal. N is the number of compounds that we do per year. If I can spell right today. And we do compounds. We have a lot of different things that we could do compounding. We could do it annually, in which we would do it 1 time a year. We can do semi-annually, which is going to be 2. We can do it quarterly, which would be 4 times a year, which is every 3 months or 4 times a year. We can do it monthly, which is going to be 12 times a year. We could do daily, which is 365. Oh, I forgot weekly. We could do weekly as well, 52 times a year. Daily, 365 times a year. We go down to hourly and minutely if we want, nanosecond. But we're gonna use these normally from anywhere from annually to daily. And then T is going to be our time in years. So if we take that $300 that we started out with up there, and at that 5% interest, if we look at 1 year, and yeah, it's just one for 1 year. So if I have A equals our principal, which is 300 times 1 plus our rate, which is 0.05, divided by, if we compound it annually, so just one time a year, n equals 1, divided by 1 time to the 1 times 1, so we're doing it one time a year and then also for 1 year, we would see that we would end up with, well, if I take 300 in my calculator times our 1 plus 0.05, so 1.05 to the first, we see that we end up with $315. That kind of makes sense, doesn't it? So we did the same thing up here, didn't we? We had 1 year, we had 5% interest, we only compounded it once that time, and we ended up with $15. But what happens if we do for 2 years? So here, if we do for 2 years, we'd have 300 times 1 plus 0.05. Again, only doing it once a year, but now we're doing it 2 times instead of just that once. We're doing it over 2 years. So now if I put it in my calculator, I have my 300 times my 1.05, which is 1 plus my 500ths. But now I'm going to take this to the second power. And notice I now have $330.75. So I've made an extra 75 cents over that period of time, that year, because I'm earning interest on that $15 that I had earned up here in my first year. So that's how compounding interest is going to work. So we're going to earn interest on any interest that we've also had. Now, what happens if we were to invest this and we compounded the interest more often? So I take this $300, I'm going to run out of room, but I'm going to get this one last example in, for 2 years, and at 5%. But now instead of compounding it just one time a year, just annually, what happens if I did it monthly? So if I did my n being 12. So now I'm going to have my 300 times 1 plus 0.05. Now instead of dividing it by my annually, my one time a year, I'm going to divide it by 12. And I'm going to have this for 2 years, so 2 times 12, or 12 times 2. Now, in my calculator, one thing that I would suggest that you do is go ahead and clean up inside these parentheses first. So I would take my 0.05 divided by 12, add 1 to it, so I get 1 point blah 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 blah, and then kind of work out just like kind of order of operations. So I would take that to the 24th power, and then times my 300. And here I end up with $331.48. So what happened? What changed? Well, I changed from here being my n being annually to now going 12 times a year or monthly. Notice I've earned just a little bit more money because I'm earning money. I'm calculating my interest each month, so I'm earning on the next month any interest on the interest I earned from the first month. And then the third month, I'm earning interest that I earned interest on in the second and the first month. See how it kind of just compounds itself upon each other. So that brings us to, well, what happens and how can we make this number as big as we possibly can? What happens if we take the number of compounds and we increase it to daily, or from weekly to daily, maybe to secondly, or after I do it one time, I do it again and again and again and again as quickly as possibly as I can do that. And we call that compounding interest continuously. And that comes up with our PERT. And we compound that very quickly. So, what happens if we do that? So what if I take my $300 at my 5% for 2 years, compound it continuously? Well, I would have my 300. Remember, E is a number. My rate is 0.05 times the number of years, which is 2. So I can put this into my calculator, which we've spent a little bit of time already this year doing. So I take my E to the 0.05 times 2, and I'm going to multiply that by my 300. So the most I can expect to earn would be $331.55. So very close to that monthly value, but notice it's, we're only working with $300 to start with, so it's only about 75 cents more, 70 cents more than what we would have had if we did it monthly. But think about if you had millions and millions or even hundreds of thousands of dollars that we were investing. Then you can do a compounded continuously interest, and you can actually earn a little bit more money. Banks, do they do it compounded continuously? Not generally. Generally, you're going to see that they're going to give you interest on your interest as a compounded interest over a month or maybe a quarterly, maybe a weekly, but generally not. Because they want to make money too. And if they're always giving their money away, then they've got to charge you more as well. So an effective interest rate, one more formula for you today, is the simple interest rate that would produce the same accumulated amount in 1 year as a compounded interest rate in 1 year. So what does that mean? Well, so what it's going to allow us to do is to take this compounded interest that we earned here and to translate it into a simple interest rate. So this $300 at 5% interest over 2 years compounded monthly. Let's go ahead and take and look at that. So if I had $300 at 5% interest over 2 years and I compounded it monthly, so what would the simple interest of that look like? And that's where our effective interest rate is going to come in. So our effective rate is going to be 1 plus my interest rate, 0.05, divided by the number of compounds, which is going to be 12 to the 12th minus 1. So again, in my calculator, I'm going to go ahead and take my 0.05 divided by 12. I'm going to add 1 to it. Then I'm going to take that to the 12th power. And then I'm going to subtract 1 from it. And I end up with this kind of ugly looking number, 0.05116, blah, 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 blah. Well, if I translate that into a percentage, then I would have 5.12% if we rounded it to 2 decimal places. So that means that in order for this compounded continuous interest to earn the same as a simple interest rate, I would need my simple interest rate to be 5.12% for them to be equal to each other. So that's where when you go to buy a car, they'll give you the APR and they'll give you the monthly interest rate, and you'll see that they're slightly different. And then it may also give you an effective interest rate, or that simple interest. So a lot of things and different ways that they can present things to you based on what they kind of want to show you and how they want to make the numbers look a little better for you, or for them to sell you the car, I guess. So what are we going to ask you to do? I'm going to ask you to use these formulas in order to solve some problems. So find the balance of an account of $2,000 invested at 4.5% interest, compounded quarterly for 7 years. So what do I know? I know my principal is $2,000. My rate is going to be 0.045. I know I've compounded quarterly, so I'm going to compound it 4 times a year, and my time is going to be over 7. So I'm going to use A equals P times 1 plus R over N to the NT. Go ahead and plug that in, so I get 2,000, 1 plus 0.045 over 4 to the 4 times 7. Again, we can throw that into the calculator. Again, I like to work inside the decimal, or inside the parentheses first. I'll take that plus my 1, and then take that to the 28th power, and then multiply that by my 2,000. Oh, I did something not right, didn't I? Well, I didn't add my 1. So 0.045 divided by 4, we'll get it right here shortly, plus my 1, there we go, to the 28th power, and then multiply it by 2,000. And I end up with $2,735.70 as my value. All right, and we have one last example here for you. If Bank Chris offered a savings account at 9% interest compounded daily, and Bank Ashley offered a savings account at 9.1% interest compounded quarterly, which bank is actually providing a better rate on your money of return? So this is looking at how do we compare these two banks to each other. Because we have interest compound daily, and here we have interest compounded quarterly. So which one would be better? So we have 9% compounded more often, but we have a higher percentage compounded a little less often. So that's where we use our effective interest rate. So we can go ahead and do, we'll do B of C, I guess, if we want, for our effective rate. So we have 1 plus our interest rate, which is our 9%, compounded daily, which is going to be 365 days a year, to the 365 minus 1. Okay, I can go ahead and throw it in my calculator. 0.09 divided by 365. I'm going to add that to 1. I'm going to take that to the 365 and then subtract 1. So I get 9.4162%. And I'm going to take this out quite far because I'm going to guess that these are going to be pretty close to each other. And as we do Bank of Ashley, B of A, I guess, we'd have 1 plus 0.091. Compounded quarterly would be to the fourth, divided by 4 to the fourth minus 1. Again, in my calculator, 0.091 divided by 4. So I'm going to add my 1 to the fourth, and then minus 1. And here I get 9.4153%. So here, notice that the better interest rate wasn't necessarily the better interest, because effectively, I see that the lower interest compounded a little more often gave me a higher interest, effective interest rate than the one that was at a higher interest rate but compounded not quite as often. Very close, and if we only went out 2 decimal places, we'd see that it would be rounded to the same value. So we may have to take these out a little farther than just to 2 or 3 decimal places. So there gives you an example of things that we've seen in the past. Some formulas, a new formula. I believe we have not talked about effective interest rate before, so that one will be new for you. If you have questions, please let me know. Good luck, enjoy, and go out and find those better interest rates.